Good evening. Now we will see that assignment number 9. And in this, we have questions on this. First question we have in a building. A beam on the outside perimeter of a floor supporting the exterior walls is called. Now we have this spandrel beam that gives in a building a beam on the outside perimeter of a floor, and that is given. So we have answer we have that is spandrel beam D. Then two ISMC 300 are placed back to back to make a batten column. If the distance between the innermost connecting weights for batten is 250 mm. So now you can see this. What is T minimum? So actually it is tie plate should not be less than. So equal to that is okay. So it is not actually greater than. So this is greater than or equal to. Minimum we have equal to. And then we can go with this, that is T minimum equal to 250 upon 50, which is equal to 5 millimeters. We have again option that is D. Then 2 ISMC 350, H is given, B is given, are placed back to back with a spacing 200 mm. If batten plates are used to make the built-up column by bolted connection, then the length of batten plate. So here it is given length of batten equal to S plus 2B. So B is given 100. So we have S is 200 plus 2 into 100. So we have 400 mm. Again option we have D. Then the cross-sectional area of this splice plate is calculated by. Now we have this one cross-sectional area of this splice plate is calculated by. So we have this value PU1 plus PU2 upon Fy. So we have that is option, we have that is A option. Then we have if the failure occurs due to crushing of compression flange or fracture of tension flange of the beam is known as. These are the three failures: bending failure, shear failure, and deflection failure. So now due to compression flange, and we know compression flange that goes to bending. So bending failure. So we have option that is B. Then we have next, if Pu is the axial factorial load and Mu is the factorial bending moment, the load for the design of splice and connection due to bending moment is equal to. Now you can see this is given. The load for the design of splice and connection due to bending moment is Pu2 is equal to Mu upon lever arm. So we have value Mu upon lever arm, that is A. Then for the design of splice, in case of bearing plate is to be designed between two column sections. The length and width of the plate is, now you can see this, in case of bearing plate is to be designed between two column sections, and the length and width of the plate are kept equal to the. So you can see here, lower story column, size of lower story column. So that is equal to again. So equal to lower story column. So we have C. Option is C. A column ISHB 300 at 576.8 Newton per meter to support factorial load 1080 kilonewton. The column section is to be spliced at a height of 2 meter. Then assume thickness 6 mm. Assume the ends to be machined for complete bearing. So this is most important. So that is given for complete bearing. If 20 mm diameter of bolts, then we have number of bolts required. So we will first find the strength of the bolt. How we will go that you know already we have to find in shear, then we have to find in bearing, and minimum of the two is strength of bolt 45.26 kilonewtons. Then assume at the end of the column section to be machined for complete bearing. As the column ends are flush, it is assumed that 50% of the load is transferred directly and 50% through splice and fastenings. So machine for complete bearing, and it is mentioned that is ends of the column section machine for complete bearing. So we have to design for 50%, and we have this is bolt value. So The direct load on each splice plate, 50% of 1080, so 540 kilonewtons. So we have number of bolts required, 540 upon 45.26, 11.93, and therefore we have value that is 12. So likewise, we have to solve the problems related with assignment number 9. Remaining problem we will see in the next video. Thank you.